Today we are going to see about Introduction to Data Structures. Why data structures? Data structures are used to organize data in memory. If you want to do any programming, you need to know the concept of data structures. In a simple form, we can say how the data can be stored in the memory is told by data structures. Before going into the topic, we have to know about the programming. What is programming? Programming is nothing but a problem which is going to be solved and the data which is involved in a program going to be organized or manipulated. The program consists of two things. One is algorithm, another one is data structures. What is an algorithm? Algorithm is a step-by-step procedure for solving a problem. That is, if we want to do any programming, first we have to know what is the problem involved in it, and then we have to find the steps involved in the problem to solve it. That is what known as algorithm. Next, what is data structures? Data structures represents logical relationship between an individual elements of data that carry out certain tasks. For example, if you want to do any additions, then we have to know what are the types of data we have and how the addition is going to happen with that. For example, if you do some mathematical calculations, then we can find too many types of data are available and how the addition operation is going to involve in it. If we go with the banking applications, then the addition operations will be done in different manner. So, what is the problem is going to be happen and how we are going to solve the problem? That is what the matter here. And what are the data we are going to deal with and how the data is going to deal. This is what said by data structures. A possible way in which a different data items or logical data items. How we are going to select a data structures. There are certain rules and conditions to select a data structures. First one, analyze the problem. So why we have to solve the problem? First we have to know, and what is the problem real is we have to know, and we have to know the nature of the problem. Then only we can solve the problem and in an optimized way. So analyzing the problem comes first. Analyzing the problem is nothing but to determine the resource constraints. So resource constraints is nothing but the thing, what are the resources it is available in the problem. We can say that analyzing problem is nothing but it is said as resource constraints. To determine the resource constraints, for example, if you do addition problems, then we have to know what are the type of data what we are going to deal with. For example, if we are going to a supermarket, we purchase something. So two types of addition is happened there. One is number of items we purchased. Next one is the total price what we have to pay to them. Okay, so it is according to the product, the price of the product will be vary, and the total number of product is also an addition problem. So this is how we have to analyze the problem first. Next, we have to determine the basic operations, whether the addition is happened with the items or it has happened with the price of the added items. So this is how we have to determine the basic operations. Then we have to select the data structures. So there are several types of data structures available. We will see one by one. Types. First, we have to know about the primitive data structures. So primitive data structures is nothing but the primitive data types what we know already. So the primitive data types is nothing but integer, floating point and all. And another type is non-primitive data structures. In non-primitive data structures, we have two items. One is linear data structures, another one is non-linear data structures. First, we have to see what is primitive. So primitive is nothing but the data types which is available. So we can say that as built-in data types or already available data types. So these are all the already available data types we have: integer, floating point, double, character and pointer. So why we have to say this is a primitive data structures? So we already know data structure is nothing but which is used to store a data. In integer also we are going to store data, and floating point also we are going to store the data. So these are all the data types which says the data or the bytes of data we are going to store in a memory. That is, integer can take 4 bytes of memory and 2 bytes of memory, and for float is taking 4 bytes of memory, double it's taking 8 bytes of memory, character takes 1 byte of memory, and pointer takes, according to the according to the data type, what is the pointer is, whether it is an integer pointer or floating point pointer or double pointer or character pointer. So according to the pointer variable, it will vary. So how? It says all the primitive data types says the memory which is going to occupy by the variable. That is why it is known as primitive data type or primitive data structures and non-primitive data structures. So we have two types of non-primitive data structures. One is linear data structures, another one is non-linear data structures. Linear data structures is nothing but a data structures which have contiguous memory allocation. Okay, so continuous memory allocation is nothing but the memory allocated continuously in a storing area. That is called linear data structures. And non-linear data structures, this is have any structures, or this is have any certain rules to store a data. It can store a data anywhere, but we have to retrieve the data whenever we want. The linear data structure is, these are all the types of linear data structures: array, list, stack, queue, or the linear data structures. Why we call these are all linear data structures? Data structures we all know about array previously. So array is nothing but the data structure which is going to store the data continuously. For example, if we say integer f4, then it will occupy f4 integer variable continuously. That is, integer variable consists 2 bytes, we all know. So we have to occupy, that is, the integer a is going to occupy 8 bytes of continuous memory. Okay, so one integer consists 2 bytes, so 4 integers in an array consist of 8 bytes. So it occupies the continuous memory in a secondary or primary devices. Okay, so wherever it stores, it continuously occupies the memory. And list. So list is also a linear data structure. So it is not a occupies the memory continuously, but it occupies the memory with the help of nodes. So node is nothing but having two areas. One is data storing area, another one is address area. So in data storing area, we have to store a data, and address area we are going to determine the next data's address, where the next data is stored into the memory is said into the list. So that is why we called that as linked list. That is a list having link with another list. Okay, so an item is going to have a link with another item. Instead of array, we can use linked list to allocate memory dynamically. Okay, so array occupies continuous memory, in case of list occupies not consistent memory. Okay, so but it will connected. Then stack is nothing but a data which is stored in a manner of last in first out manner. Okay, so that is, in stack we are going to store a vast amount of data and we are going to pick the data from the top. For example, if we arrange a book in our table, a stack of 10 books are arranged in a table, then we want to take any book means you have to take from the top only. That is what said as stack. Next one is queue. Queue is nothing but a queue manner or queue of anything. It may be a ticket counter or it may be a something queue in an ATM or in a vaccination area. So in a queue, it works in a manner of first in first out. We say that FIFO manner. So that is the who are going first into the area that will be considered first to act. That is what queue is. Next one is non-linear data structure. So non-linear data structures consist of two types. One is trees and the one is graph. And trees and graphs are we will see later on classes. And common operations which is involved in a primitive data types. Common operations involved in abstract data types. Abstract data types are nothing but non-primitive data structures are called as abstract data types. So all those things, arrays, list, stack, queue, trees, graphs, all are come under non-primitive data types. The common operations which is involved in the abstract data types are, first one is searching. Searching is nothing but a data which is we are going to store already and we want to fetch it, then we go with the searching. Next one is sorting. Sorting is nothing but the sorting of data in an ascending order or descending order. Whatever the order we need, we can arrange it in an order. Third one is insertion. So if you want to insert a new element into a data area, then we will go with insertion. Next one is deletion. So if you want to delete any data, then we have to use this delete operation to delete an data from an abstract data type. The last one is update. Update is nothing but the data which is modified after storing it. That is what called as updation. So these are the common operations which is involved in the abstract data types. So abstract data types are nothing but the non-primitive data types are known as abstract data types. So today we see the introduction about data structures. So data structures are used to store the data, and to storing a data we will have too many types of data structures. So data structures are come under two types, primitive as well as non-primitive. Primitive data types are store a small amount of data, and non-primitive data types are used to store a large amount of data. In non-primitive data types too, we have two types. One is linear, another one is non-linear. Linear data types are occupies continuous memory, or it is organized in a manner. A non-linear data structures are not occupies the continuous memory, but it will link together. Okay, that's all for the introduction to data structures. Arrays, the concept of arrays we will see in our later classes. Thank you.